Welcome to another lecture of orthographic projection. In the last lecture, I have discussed about the projection theory, types of projection like perspective and parallel projection have further two types, orthographic projection and oblique projection, and the orthographic projection has further two types, that is axanometric projection and the multi-view projection. So now we are discussing the orthographic projections. In this lecture, I will cover the following topics like project, representation, multi-view projection, glass box concept, orthographic projection of point, line, plane, surface and object, and at the end line conventions like which line is important, center line, solid line, hidden line, so etc. Here is the object representation. For the object representation, we have under the subheading of orthographic projection, that is under the orthographic projection, that is two types, axanometric projection and the multi-view projection. So in the last lecture, I have also discussed that axanometric projection gives three dimensions in one view, and multi-view projection we have to draw multiple views to get the object features and the shape. And axanometric projection do not give the actual size and shape, but the multi-view projection gives us actual shape and size. So that's why in this lecture we will follow multi-view projection, how to draw the multi-view projections under the subheading of orthographic projection. You can see this is an object, 3D object. At the top there are two holes, and on the side there are two setbacks, cuttings. Okay, so when we see this object from the top, okay, so you will see left side, right side, and at top two circles. Okay, so here two center lines are shown, center line, long dash, short dash, long dash. Similarly in the vertical, the center, the second circle here. And when you see from this side, you will see this solid face. Okay, this solid face, and you also know that there is some hidden feature, like behind this there is circle. So to show this circle, we use the dash line for showing the hidden object. So here at the same location, dash dash dash, similarly here dash dash dash, so that is showing the location of hidden feature, and for the circles center line is shown. So that is the multi-view projection under the subheading of orthographic projection. Multi-view projection, now we will discuss in this lecture only multi-view projection that are important for our generation of drawing sketches for engineering purpose. So there are three principal dimension of an object. Okay, so width, length and height. You can also say width, height and length. So can be represented only two in each view. What it means here, you can see when the observer see this object from this side. Okay, so then he will see width and height of this object, width and height of this object. Now we do not, in this object, if we show this drawing to the client or to the other person, he will not able to understand what is the length of this object. So for the length of this object, we have to draw also one view. Now the observer will see from this side, from right side of this object, here is the drawing. When the observer will see from the right side, he will see this face and this face, and there is a cutting, so that will be shown with line. That is a right side. When the observer will see from the top, he will see three sides, 1, 2, 3, just like that. Now with side view, that is right side view, we also getting the length, and from the top we also getting the length. So it means if we erase one of the object, one of the drawing of multi-view drawing, either this one or this one. So our purpose will be fulfilled. So it means can be presented only two in each view, means either we can use this view and this view, second this view and this view. That will be enough for the full representation of this object. To obtain multi-view representation of an object, here there are two methods. Revolve the object with respect to observer, mean observer will remain static, mean the person that is the observer who is observing the object will remain static and the object will be revolved. Second, the observer move around the object, means now the object is static, observer will move around. I will explain one by one. First, when the revolve the object with respect to observer. Now here, see, so this is same face, this is same face. Now I'll rotate this object to my towards my side, means towards the observer, here, here and here. You can see I have revolved this object. Now I will see this side, this bottom and this front. So that is the front view. Now I will rotate the other, here, rotating again. Okay, now you will see L type shape. That is the right side view. Now I will rotate the object so that I can see from the top. Okay, so now you can see we will see this view. This is the, in this we have revolved the object, means the person is at the same position, he is not moving. We have revolved the object. Now in the second case, observer move around. When okay, here is the plane of projection. When the observer will see this side, this one, this one, this is the front view. Now for the right side view, the person will move towards this side. This is the right side view. Now the observer is moving. Now the observer will move at the top. That is the top view. Now that is just like we have placed the glass, or you can say a mirror. The object shadow is occurring on this face, similarly on this face and this face. We got three views: front view, top view, right side view. Now see, here a hinge or a pin is applied. Now I will open this face towards the right. Similarly, the top one, hinge or pin is applied, just like door, towards top side. Okay, now next one. Here, when we see the object from the downside, bottom view, then here, when you will see this object from the bottom, you will not see this cut. So, but you know there is a cut. So you will represent with dash line as a hidden feature object. From the left side, when you will see again L shape will be displayed, and from the rear, means from the back side, this is front, from the back rear view, again you will see the plain face, but you know there is a cut. From the inside, you will represent with dash line, that is a hidden feature. That is a glass box concept. Okay, all these 6 views are shown in this slide. Okay, so this is a glass box concept. Object is present in the glass box and shown with different shapes. different views, multi-views. This is a top view, front view, right side view, left side, top, bottom, and rear view. Height. We can measure the height from front view, from right side, from left side, and from the rear. Similarly, we can measure the width from top view, from front view, from bottom view. Okay, so third, depth. We can measure from the top view, that is the length. Again, we can measure from the right side view, left side view. Okay, so you can see if we show only these three, top view, front view, and right side view, you can understand this is a L-shaped object. When you will see the front side, okay, this will be shown. When you will see from the top side, so you can see from the top side. So it means these three views can show us width, length, and height. That will be enough for this object representation.